this computer. Awesome. Okay, so this is our week 11. We are dealing with chapter 12. So I received some emails from students asking me to go through some specific questions, which I will do. So the first question here is, let's see. So the first question, 7 months ago, you purchased a stock at a price of $36.04 a share. Today, you sold those shares for $43.15 a share. During the past 7 months, you have received a dividend totaling 24 cents per share, while inflation has averaged 3.6%. What is your approximate real rate of return on this investment? Okay, so I trust you have learned the first finance courses focusing on personal matters, right? In that course, you should have learned this, right? So you have a nominal return, right? You have a nominal return, but this return is not a real return if you consider the inflation rate, right? You have inflation, especially right now, the inflation is very high, right? The inflation rate. So this inflation rate is gonna reduce the nominal return. So that return is called a real return, right? So it doesn't appear that you are earning that nominal return. Why? Because the money you earned does not have as much purchasing power as before because of the inflation, right? So therefore, there's a discount on the nominal return. We call the real return. Okay. So did you learn this before or not? I think you have learned this before. And then the formula is that so 1 plus this nominal return, if I use Rn, should equals 1 plus the real return, I use lowercase r, times inflation rate, RF. Okay, so this RF is inflation. This lowercase r is real return, and this Rn is nominal return. So the model, the formula is this. Have you learned this before? In the first finance course, do you remember this? Yes. Okay. Good. Okay. So in this case, if you keep developing this formula, right? So you have the multiplication of 2 bracket. You're gonna break the bracket, right? We are doing a little bit of algebra. So you get 1 plus 1 plus RF and E plus R times RF. Right? So often, if you have a small number R, you have a small number RF, the multiplication will be even smaller, right? So often, if the R and the real return and the inflation rate, if they are very small, right? So think about this. If it's 1%, 1%, so 1% times 1%, that's like 1 out of 10,000, right? It's very small, right? So when R and RF is small, this one can be ignored. So this one is approximate equals to 0. So that's why they are asking you this, approximate, right? So now the equation become 1 plus Rn equals 1 plus R plus RF, right? So now you can take this one out from both sides. So what is your real return? Your real return is Rn, the nominal return, minus RF, right? The inflation rate. So we know this number is 3.6%. And we want to know what's my real return. So now the question comes down to find out what's your nominal return, right? So what's your nominal return? So this should be pretty straightforward, right? So your return includes two parts. One is dividend. So that is dollar amount. So that is 0.24, right? So that is your dollar amount for the dividend. And your capital gain, CG, capital gain, that is your selling price, 43.15 minus your purchasing price, 36.04. So that equals, if I'm correct, that's gonna be 7-Eleven. Oh boy, this makes me even more hungry. 7-Eleven, okay? I was talking to, in the beginning, have a conversation about I'm fasting right now, okay? So I'm relying on only juice, vegetable juice. So today I didn't eat any other real food. I'm really hungry. Now I get a result, 7-Eleven. Boy, this makes me even more hungry. Okay, so just give me 1 second. I want you to figure out what's your RN, okay? So just 1 second. Please figure out what's your RN. So anyone get the result? The total return, you have two components, right? One is dividend, one is capital gain. Okay, yeah, somebody got a result already. Thank you. So now you use total return, including two components. So dividend and the capital gain. So together, I have 0.24 plus 7.11, right? So this would be my 735, right? Yeah, 735. And this is my dollar amount, right? But in this calculation, the RN is in percentage, right? So when I'm thinking about my return in percentage, right? In percentage, so this is my dollar amount refers to the initial price, purchasing price. So you get $7.35 out of your investment, which is 36.04, right? So let's see if then his number is correct. Let me do this. 7.35 divided by 36.04 equals, good job, yeah, 0.2039. So that's roughly 20.4%. Okay, so now I know this is my nominal return. So when I bring this number here, 20%, 0.4, and then minus 3.6%. So this gives me 16.8%. Okay, so are we clear with this question? If yes, give me a thumb up. 1, 2, 3. Are we clear with this question? Okay, awesome. Awesome. Note that if they ask you what is your real rate, if this word is important, approximate. If the question does not have this information, then you have to use this original formula. Okay, you have to use this formula, right? So you enter that 20.4% here and 3.6% here. So your 1 plus R equals 1.204 divided by 1.036. Okay, let me do this. So see what I got here. 1.204 divided by 1.036. So this is 1.16216. So my R will be 16.22%. Okay, so now you can see that approximate, right? So that means they just want you to know a rough number. Is a little bit over exaggerated, right? So 16.8. But if you do not, if you calculate the actual number, not the approximate number, so that should be 16.22%. So you just have to know how to do this, right? When you are depending on how you are asked, right? Okay, so now let's move on to the next question. Okay, so let me erase all the ink slide. So this is how I calculated it. Okay, so next question is that theta stock returned 2%, negative 5%, 12%, 28% for the past 4 years, respectively. This order is important, right? This order, 1, 2, 3, 4. You can't mix up this order, right? That's why they are saying respectively. So emphasizing the order of the return, which one comes first, which one comes later, right? Based on this information, what is the 95% probability range of return for any one given year, right? So we are talking about normal distribution, right? Have you guys learned about some business stats? Have you learned about what is normal distribution? What is the mean? What is the standard deviation, those stuff? Do you know? Okay, Keaton said you have learned. What about you, Godfrey and Dante? Have you guys learned about this normal? Okay, good. Okay, so what is the 95% probability range, right? So well, the return mostly happened to be the most likely happened return would be the average return, right? But then if you think about the range, so what is the chances of any year the return fall into a range with a 95% probability, right? That's basically the question. So here, let me do this. First, you calculate the arithmetic average return, and that's pretty easy. So you sum the return up divided by the number of observations, 4, right? So 2, the reason why here is a negative is minus because it's a plus negative. So that's a minus 12, 28, right? So I figured out this would be 9.25. That's my arithmetic average return. Okay, so next step, I'm going to calculate standard deviation. Well, now first, I'm going to calculate the difference between each return, each observation, and the average. Okay, so the first one, see, this is all the observations, right? For this is all the observations, the actual return. And so I'm taking the difference of the mean. So also another word for average, but it's the stats, right? The mean, 9.25, which I just calculated, right? I'm taking this out of each of the actual return. And then I do a square, okay? Then I do this square. So I figured out this squared difference, right? The squared difference. And now I'm going to sum them up. So when I add up all this, I get this number, okay? Because I need this number to calculate my standard deviation. So what's your standard deviation? Okay, remember this number is squared, right? But in order to get my standard deviation, I have to do a square root, right? Square root of this sum, but this one has to be divided by n minus 1, okay? This n is your observation. The reason why it's 1, why minus 1? Because you lost the degree of freedom, right? Because the way how you calculate your average, right? So you used this 4 number together, right? 1, 2, 3, 4, and you divide it by 4, and you get this average, right? So this number is calculated using these 4 observations, right? So that's how they were bound together. They lost 1 degree of freedom. So here you have to use this observation. There are 1, 2, 3, 4 observation, n equals 4, but you have to minus 1 because you lost the freedom. Okay, so this is going to be like square root 614.75 divided by 4 minus 1. Okay, so what I got here is 14.3149. So usually in the stats terms, the symbol for this for the mean is mu, right? And for this one, standard deviation is this sigma type of symbol, okay? So what does this mean? Okay, I'm gonna show you the picture. Okay, so in this normal distribution, normal distribution, this is the mu, this is the average, the mean. So if you consider a 1 standard deviation from the mean, so that means I'm gonna go from the mean to the left by a distance of 1 standard deviation. Okay, so this is my left point. I'm also going from the mean, the middle, to the right side by the distance of 1 standard deviation. Okay, so now I have a range, right? This range is the distance of the range is actually 2 standard deviation centered at the mu, right? Because this distance would be 2 standard deviation, right? And it's centered by the mean, right? So with normal distribution, okay, for any observation fall into this range, okay, the probability is 68.2%. Okay, so for the one standard deviation range, right? So you go from to the left one by one to the right by one. So the range is totally 2 standard deviation, but it's centered at the mu. In this range, right, your return will fall into this range. Okay, that probability is 68.2%. Does this make sense? If you have learned the stats, give me a sum up if you understand this. 1, 2, 3. Okay, thank you, Keaton. Thank you, Dante. Okay. Now, so now if I go by 2, okay, so now if I'm going, okay, I'm gonna pick a different color. Now, if I'm going from the mu to the left by 2 standard deviation, to the right by 2 standard deviation, so I'm widen the range, right? I make the range wider, okay? And in total, I have a 4 standard deviation. It's also centered at the mean. So I'm making the range wider. So I'm going to capture more returns, right? So then for any year, that opportunity probability of the return fall into this wider range is increased. So it's increased from 68.2% to 95.4%. Okay. So here they were asking, what's the 95 probability range of return for any one given year? So they were asking this range. How do you know this range? Well, the left point, okay, the smaller return would be your mean, the mu, minus 2 times standard deviation. Okay. So how do you know the upper bound of the range? Well, that would be your mu add 2 standard deviation. Okay. And so once I know this lower and upper range bound, so that range will define a probability of 95%, right? If you keep going, so if you move towards each side by 3 standard deviation, you almost capture everything, 99.7%. Okay, so in our case, I'm doing this calculation. So I'm calculating what's my mu. My mu is average 9.25. So I want to know the upper bound, right? Upper bound. So 9.25 plus 2 times the standard deviation. That's the standard deviation. So I get 37.88. So if you want to know the lower bound, I use the mean to minus 2 standard deviation. So I get a negative 19.38. Okay? So does this make sense, everyone? If you understand this, give me a sum up. 1, 2, 3. Thank you, guys. I'm glad this all makes sense to you. Awesome job. Okay, so now I feel happy. I can move on. Okay, so this one is question 7 from the textbook. Okay, this one is question 7 on page 463 of the textbook. So this question is asking that using the following return, calculate the arithmetic average return, the variances, and the standard deviation. Okay, so let's do X together, and you are going to do Y by yourself. Okay, so let's take a look at X. So this is the information for X. We have a 5-year observation, and the return for each year is provided. Okay, and then let's first add them up. Okay, so when I add them up here, I get 0.46. Okay, and there are 5 observations. If that's divided by 5, I get my average to be 0.092. Okay, so my average is 0.092. And now I need to calculate the difference between the actual observation and the average. So here, for example, this first year, I use 0.15 minus 0.092. So I would get 0.058. Okay, so that's my result. And the next step, I will do a square here. I will do a square. Okay, so here 0.058, I do a square, so that equals this number. Okay, does this make sense? Okay, good. And now, if you know how to use Excel, that things will making it be really easier, right? Do you guys use Excel? Because if you use calculator, calculate each of them, it just take more time, right? But if you have Excel, things can be very easier quickly. Do you know how to do that? If you know, give me a thumb up. 1, 2, 3. Okay, good. Yeah. So try to do that because it's gonna save you some time, right? If you don't know how to use Excel, I mean, it's a very good tool. You definitely want to start to learn how to use it. Okay. So once you have all this difference number, okay. So now I'm gonna add them up. So when I add them up, I get this number. Okay, this is my sum of the squared difference, right? So, and this is my variances. Okay, that is called my variances. This is my variances. And now the next step, you calculate the standard deviation. Okay, so you use the variance divided by observation n equals 5 minus 1. So, and then you do the square root. So you get 0.142898, right? This one. Okay, good. So I'm gonna give you 3 minutes. You're gonna do y, okay? Please do this y and let me know your result, okay? I'll give you 3 minutes. This is the y information. I'm gonna circle it with the green color. So now you do the y, using the y information to calculate the mean, the average return, the variance, and the standard deviation. Okay, I give you 3 minutes. Okay. Okay, anybody got the result yet? Did you get the standard deviation? If you have the answer, let me know. Yes, that's correct. 0.2297. It's at the top of the screen. Standard deviation for, yeah, you both are correct. You both are correct. Yeah, 0.2297. So I'm going to show you how I calculate this using. I'm going to show you how I calculate this using Excel. So then you would have an understanding of, how efficient, how beneficial to use Excel. Okay, so let me open this Excel. Okay, and let's see. Can you see my screen? Okay. Is this big enough? Can you see my Excel sheet? So year one. Can you see? Yeah. Okay. Year one, and so I have 2, 3, actually 4, 5, right? Okay. So here for Y, the first one is 0.21, second one is 0.36, and 1.13, and negative 0.26. Actually, yeah, year one, I got this wrong. Yeah, so year one is here. And year five is 0.15, right? So I get all this. I need a. So here, this is my Y return. So if I need to know the mean, right? The mean, so it's pretty easy for me to do. I do a sum. I'm gonna go like this and divide it by 5, right? Okay, so now I'm going to just okay, so if I go this, and now I calculate the difference. So I use this one minus the mean. So I get all this difference, and then I do the squared difference. So I'm going to use this number divided by 2. Okay, so now my variance would be the sum, right? I'm going to do a sum here. Okay, and then my standard deviation. So will be equals actually this number divided by 5 minus 1, so that's 4. And then I need to do a square root, right? So is that the same number you got? 0.2297? Yeah. How long did that take me to use this with Excel? Is this how you do it? Dante, Godfrey, you guys get the result? Is this how you do it? Okay, awesome. I'm glad to see that. Yeah. So it doesn't take 3 minutes, right? It should be much quicker than that. Okay, then he used your calculator. You must press the button very fast. Okay, good job. Yeah. Do you like the Excel way? Sometimes when you use a calculator, it could be very challenging, right? You may press the wrong button, right? Oh, you like Excel, but you can't use it in the exam. Yeah, that's too bad. But it's important, right? Maybe in some other exams, you can use it. Yeah. Okay, so are we okay with this question? Do you find that you have enough time in the exam because you are using calculator, right? So I try to give you double time because I understand that you are, using calculators. Do you find you have enough time for the quizzes, for the midterm exam? Or last exam you have plenty of time? Okay, good. Yeah. Okay. Awesome. So let's keep going. Okay, so this question is question 16. So question 16 is from the textbook, okay? From textbook question 16. So what do we have here? So we are doing a stock has had the following year-end prices and dividend. What are the arithmetic and geometric returns for the stock? Okay, so first we're gonna calculate the return, right? So in the previous question, those returns were given, right? So you just do it directly. So this question requires a two-step, right? The first step, you have to calculate the return, right? So in this example, it's a stock situation. I also use the Excel, but so you know the price, you know the dividend. So you calculate the dividend yield, right? So dividend yield equals this year's dividend divided by the opening price of the year. These prices provided are year-end prices. So if you see the price is $60.18 for year one, that means this is the price at the end of year one, right? Because it tells us this is the year-end price. So if it's the year one year-end price, that will be the opening price for year two, okay? So when you calculate the dividend yield, you always use your dividend divided by the opening price, okay? So it goes like this. The direction goes like this. Oh, that's okay, Candy, Kidan. Yeah, you would watch the remaining videos, okay? We're almost done, yeah. Have a good evening. So you always go by this, right? You go by the dividend divided by the opening price, right? So then I can figure out the dividend yield, right? This is how I got it. So for example, this one is 0.6 divided by 60.18, right? So that's close to 0.1% here. There's no result here, right? Because there's no dividend, okay? There's no dividend. There's no information of the previous years, right? This is the first year. So now I calculate all the dividend yield, right? Now I need to capture the capital gain yield, right? How do you calculate the capital gain yield? Well, you use the closing price minus the opening price. That's your capital gain divided by the opening price. So in this case, I use 73.66 minus 60.18 divided by 60.18. Okay, that's how I got this number. And now you know the two yields, when you add them up, you would get your total return, right? This is in percentage. This will be in percentage, right? Okay. So then you can see that I calculated the return in percentage for year 2, 3, 4, 5, 6. So I have 5 observations, right? So 1, 2, 3, 4, 5. I have 5 observations. Okay. So what's my average of this 5 observation? What's the average? So I add them up. I add this up. So I get the total return. That will be, oops, that will be 0.5913. And there are 5 observations. So I use 0.5913 divided by 5. So that equals my 11.83%. Okay, that's my average. And we call this arithmetic average return. So the word here is arithmetic, right? And now, how do you calculate the geometric return? Right? How do you calculate the geometric return? So this time, it's instead of you using the sum, you use multiplication, right? Use multiplication. So the first year, 1 plus the return, okay? So that's how much they grow. And you multiply it by the second year, 1 plus the return, multiply the third year, which is the loss, 1 minus. And the fourth year, sorry, I mean the fourth observation, 1 minus, this is also a loss. And the last one is 1 plus, okay? So you use the multiplication, and then you do the square root, right, to the power of 1/5, right? And then you minus 1. So you get 10. So you get 10.58%. Okay. Does this make sense? In terms of how to do the calculation for the different average return. One is called arithmetic average return. The other one is called geometric return. Does this make sense? 1, 2, 3. Yeah? Okay, good. Now, did you notice something? Which one is higher? Do you think arithmetic return is higher or the geometric return is higher? So in this case, you can see that the arithmetic return is higher, right? Slightly higher. Okay. That's it for today. Do you guys have any question? Do you have any question I can address? Are you happy and okay? Give me some up. 1, 2, 3. Okay, awesome. Thank you, both of you. I appreciate your company. Okay, make my teaching a little bit easier. Otherwise, if I do it by myself, it's quite boring. Yeah. Okay. Awesome. Well, have a good evening, everyone. And I'm going to stop my recording. Please